Divisibility test. A big numbers we can check by through simple methods divisible by these numbers or not. First, a number is divisible by 2 or not. For that, look at the given number and its units digits ending with or units digits is 0, 2, 4, 6 or 8, which means the number is an even number, then that number is divisible by 2. Divisibility test of 3. Sum of all the digits in a is a multiple of 3. Sum of all the digits. First you have to add all the digits of the given number and that is a multiple of 3. Then we can say the given number is divisible by 3. Divisibility test of 4. The last two digits of the given number. If the last two digits, that means ones and tens digit, it's divisible by 4, then that given number, big number also divisible by 4. 5. The number ends with 0 or 5, then the given number will be divisible by 5. For 6, the number is divisible by 2 and 3. That's supposed to be an even number and also divisible by 3. 3 that we had to check by using this method. First you have to add all the digits and that is a multiple of 3, then we can say that number is divisible by 3. If it is an even number, then we can say that is divisible by 2. If both 2 and 3 divisible by 2 and 3, then we can say the given number is divisible by 6. For 8, last 3 digits divisible by 8. Then the given number that will be divisible by 8. 9, sum of all the digits is a multiple of 9. Same as that 3. If all the first you have to add all the digits and that sum is a multiple of 9, then we can say the given number is divisible by 9. 10, if the number ends in 0, that means unit place digit is 0, then we can say that number is divisible by 10. Figure it out, page number 125. First question, 2024 is a leap year, as February has 29 days. Leap year means February is having 29 days. Leap years occur in the years that are multiples of 4, except for those years that are evenly divisible by 100 but not 400. From the year you were born till now, which years were leap years? We can take that 2010 or 9 if you want. Then after that the next leap year is 2012, then plus 4 with that. 2016, 2020, then 2024. Second part, from the year 2024 till 2099, how many leap years are there? So we can write in order. Just keep on adding 4. 2024 is a leap year. Then 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, 80, 84, 88, 92 and 2096. So there are altogether 19 leap years from 2024 till 2099. Second question, find the largest and smallest 4-digit numbers that are divisible by 4 and also palindromes. Palindromes means when we are writing forward and backward, the same order keeping numbers. Now the largest 4-digit number which is divisible by 4 and also palindrome, which means 8,888. And the smallest number also, smallest 4-digit number divisible by 4 and is also palindrome, that is coming 2112. Here we can see the numbers when we are writing in forward 2, 1, 1, 2. If we are starting from here also, we will get the same number 2, 1, 1, 2. So these type of numbers are called palindrome. Now the third question, explore and find out if each statement is always true or sometimes true or never true. We can give examples to support your reason. First one, sum of two even numbers gives a multiple of 4. So we can write that not always, sometimes true. So not always, or we can write that as sometimes. sometimes true. Example, 6 plus 4 is equal to 10, which is not divisible by 4. Adding two even numbers, not always a multiple of 4, which is not divisible by 4. Here 2 plus 6, 8, which is divisible by 4. Second one, sum of two odd numbers gives a multiple of 4. Here odd numbers 7 and 3, if we are adding 10, which is not a multiple of 4, 7 plus 5 is equal to 12, that is a multiple of 4. So there also sometimes these statements it will become true. Here divisible or multiple we can write it. Question number 4. Find the remainders obtained when each of the following numbers divisible by 10, 5 and 2. We can take the first number 78. 78 when we are dividing by 10, we know that 7 is the quotient and 8 will be the remainder. So remainder only we have to write here. Remainder is equal to 8. 78 divided by 5. So it will come 8 minus 5, 3. 3 is the remainder. 78 is an even number. So when we are dividing by 2, remainder will be 0. Next number 99. 99 divided by 10, remainder will become 9. Because 9 times 10 in 90 and then 9 is the remainder. Dividing by 5, 9 minus 5, that means 4 is the remainder. 99 is an odd number, so dividing by 2, 1 will be the remainder. Now same way the rest of the numbers. Next one, 173 divided by 10. Here we can see 3 is the remainder. Dividing by 5, there also 3 is the remainder. Dividing by 2, 1 is the remainder. 572, here 2 is the remainder. Here also dividing by 5, there also 2 is the remainder. It's an even number, so 0 is the remainder. Next number 980. In ones place 0, that means which is divisible by 10, remainder is 0. Divisible by 5, remainder is 0. Divisible by 2, remainder is 0. Next number 1111, dividing by 10, 1 is the remainder. Dividing by 5 also 1, and by 2 also 1 is the remainder. Next number 2345, dividing by 10, 5 is the remainder. By 5, this number is divisible by 5, so 0. So an odd number, therefore remainder, when we are dividing by 2, remainder will come 1. Fifth question, the teacher asked if 14,560 is divisible by all these 4, 2, 4, 5 and 8 and 10. Guna checked for divisibility of 14,560 by only 2 of these numbers and declared that it was also divisible by all other numbers. What could those two numbers be? We know that 2, 4, 8. These are the multiples. If he checked with 8, then automatically that number will be divisible by 2 and 4 also. If he checked by 10, then that number will be divisible by 5 also. So the numbers he checked may be that 8 and 10. So we can write, if a number is divisible by 8, it is also divisible by 2 and 4. Because 8 is a multiple of 2 and 4. If a number is divisible by 10, then also we can write it is also divisible by 5. Therefore, Purna could check the number 14,560 by 8 and 10. Question number 6. Which of the following numbers are divisible by 2, 4, 5, 8 and 10? We can see these two numbers are not divisible by 10 because unit place digit is not 0. So these two cannot divide by 10. Here all these numbers can divide by 10 and also by 8. 8 is a multiple of 56 is a multiple of 8. Here 3 zeros are coming, that means that also we can divide by 8 and this. So the answer is these three numbers are divisible by all the given terms. Question number 7. Write two numbers whose product is 10,000. The two numbers should not have 0 as the units digit. So first we have to split the 10,000 as 10 into 10, 10 into 10. And again this 10 as 2 into 5, 2 into 5, 2 into 5 and 2 into 5. We can write all 2's together. 2, 2, 2, 4 2's are here and 4 5's are there. So when we are multiplying these 4 2's, we will get 16 and 4 5's 625. So the numbers are 16 and 625 are the two numbers whose product is 10,000 and not ending with 0.